Good morning to all of you. This is Somshekar, Assistant Professor of Mathematics, Sarambi Government Science College, Mamunkatte, Bhadravati. Welcome to my second session of first order and higher degree differential equations. In the last session, we learned the equations which are in soluble for p time. In this session, we are going to learn the equations which are in soluble for x time. Without wasting the time, let me come to the main content. Suppose this is the given equation, f of x by p is equal to 0, call it as 1. First of all, find for x. After finding x, the RHS terms are definitely in y and p. That means it is a function of y and p, call it as g of yp. Differentiate this with respect to y. The derivative of x with respect to y is dx by dy is equal to, and please observe the right hand side terms. The right hand side terms may contains, if the function contains y square, now the derivative of y square with respect to y is 2y. That means the RHS term may contain y. If the function contains p square, then the derivative of p square with respect to y is first of all 2p. That means the RHS term contains p, and the derivative of p with respect to y is dp by dy. That means the RHS terms are involved in yp dp by dy. It is a function of yp dp by dy, call it as h. Now this whole equation contains, we already know that dy by dx is p. Therefore, dx by dy is 1 by p. Replace dx by dy by 1 by p. That means this whole equation contains yp dp by dy. And this is the first order, first degree differential equation in p and y. Solve this equation. After solving this equation, the solution is like this. We know that the solution is the relation between dependent variable and independent variable. That means py. Since this is the first order, first degree differential equation, it contains one arbitrary constant, say c. Therefore, the solution is of this format. Function of pyc is equal to 0. Call this as 2. Now the equation 1 and 2 contains p. Eliminate p between 1 and 2. The equation what we got is the solution of the given equation. If it is not possible to eliminate p between 1 and 2, then write x and y in terms of p. Let me take some examples. Solve x is equal to y plus p square. And this is the given equation, call it as 1. Here already x is solved. Differentiate with respect to y. Dx by dy is equal to, the derivative of y is 1 with respect to y, plus the derivative of p square with respect to y is first of all 2p into the derivative of p with respect to y. The notation is dp by dy. Now dx by dy is 1 by p. dy by dx is p, and therefore dx by dy is 1 by p. Is equal to 1 plus 2p dp by dy. Now this equation contains p and y. Separate the variables. 1 by p minus 1 is equal to 2p dp by dy. Take p LCM. 1 minus p divided by p is equal to 2p into dp by dy. And separate the variables p and y. Bring the p terms with dp. After cross multiplication, p into 2p square divided by 1 minus p into dp is equal to, here it is 1 into dy. After the separation, we have to integrate this. We already know this method. At this stage, we can't integrate. We have to make this term where the integration is possible. How can we make? 2 into have this denominator term 1 minus p in the numerator. We can achieve like this. In the numerator p square, subtract and add 1. P square minus 1 plus 1 divided by, take negative common in the denominator, negative of p minus 1 into dp is equal to dy. Minus 2 into, now this is of the form a square minus b square, a minus b into a plus b, p minus 1 into p plus 1 divided by p minus 1 into dp is equal to dy. Minus 2 into, split this term, this term divided by p minus 1, p minus 1 gets cancelled, it will be p plus 1 plus 1 by p minus 1 into dp is equal to dy. Now we can integrate the each term. Therefore, on integration, minus 2 into the integration of p is p square by 2 plus the integration of 1 is constant into p, 1 into p plus, now the denominator is the linear term in p, and therefore the integration will be log of p minus 1 is equal to integration of 1 with respect to y is y plus some constant c. Multiply by minus 2. Now this implies 2 gets cancelled. Minus p square minus 2p minus 2 into log of p minus 1 is equal to y plus c. Call this as 2. This is the equation 2 is the solution of this equation. dx by dy is equal to 1 plus 2p into dp by dy. Now the theory says eliminate p between 1 and 2. Find p value in any one of these equations 1 and 2 and substitute in another equation. Here finding p value is easier. Here finding p value in the equation 1 is more comfortable than in the equation 2, and therefore find p value in the equation 1 and put this value in the equation 2, and definitely p will be eliminated. After finding p value using the equation 1, we have p square is equal to x minus y, p is equal to square root of x minus y. Now 1 implies p is equal to square root of x minus y. Put this p value in the equation 2 and definitely p will be eliminated. Now 2 implies minus of p square is x minus y, p square is x minus y, minus 2 into p is root of x minus y, minus 2 into log of p is root of x minus y minus 1 is equal to y plus c. Here in the LHS we have minus into minus y plus y, and also in the RHS we have plus y, and therefore these two gets cancelled. After bringing plus y to the right hand side, we have plus y minus y, these two gets cancelled. Ultimately we have minus x, and the remaining these are same, equal to c, and this is the required solution. Here one more problem is there, and this is the reference for you. Please go through this and also go through these exercise problems. If you have any query, please follow these references. Thank you one and all. See you in the next session.